And so I want to kind of explain to you guys what causes learning disabilities and where it comes from, okay? It's really just how the brain's working. And so I'm going to kind of explain to these. This is not a picture of a butt, so you're not a butt head. This is literally your brain, okay, with a really bad drawing and my horrible artistic skills, okay? So this is your right hemisphere, and this is your left hemisphere, okay? This is the corpus callosum that comes down the middle. So that's looking at your brain from this direction. Okay, this is also your brain. If you were to slice it in half this way and then look at it this way, this is this diagram, okay? And then this is looking, if you were to slice the brain this direction and pull off the front, you're looking at the back. Okay, so these are 3 diagrams of your brain. You have to apologize for my artistic or lack of artistic skills, okay? But your brain is very much like a peanut M&M. How many like peanut M&Ms? All right, so next time someone calls you a peanut brain, there's a little bit of truth to that, all right? There's this outer layer, okay, and this is that noodly part you see, and that's called the cerebral cortex. This is all gray matter, okay? Gray matter does all the processing, storage of your brain, okay? And it's that it's kind of like a noodle layer that goes around the outside. And so from this perspective, it would look like this, okay? And it's this outer layer of the brain. Well, I said your brain's kind of like a peanut M&M. On the inside in here, there's also some gray matter. And this does all your processing and storage, okay? Everything else is white matter. This is your high-speed cables. This is how you get information from here to here, here to here, here to here, here to here, and back and forth. Left, right, front, back, top, bottom. Okay? When you lose a connection or a part of the brain stops working, you lose abilities. Does that make sense? Okay, so for example, your eyes sit right here. Okay? Your right eye is processed on the back left side of your brain. Doesn't make sense, but that's where it goes, okay? So all the stimulation from your eyeball has to come to the back and cross from here to there to be processed. Now, everything that passes through the lens of your eye is reversed and flipped. So the back of your eye actually sees everything upside down and backwards. And it sends the signal back to here to be processed. When it crosses the corpus callosum right here that connects your left and right hemispheres, it reverses and flips them again. So on the back of the brain, it's processed in the right order. So what happens with true dyslexia, where you're flipping orders and flipping letters around, this corpus callosum shuts down, or parts of it, so you can't get that back. So this right eye gets processed on the back right side of the brain, which puts everything backwards and upside down. Okay, so if you have a B, okay, that's what a B looks like, right? This is what a D looks like. This is what a P looks like. And that's what a Q looks like. You understand dyslexia now? Pretty simple, right? Like, oh yeah, that's why the back of the brain I see D and I say P, Q, or B, right? And I say bog instead of dog when I read it. Because as my eye read dog, the back of the brain saw P or B, and I say bog or pog. Make sense? Okay. So if this white matter, the white matter is in here, okay, the gray matter is this inner core and this outer core. If you lose function with this gray matter or white matter, you lose the ability to do things. But luckily the brain is fluid, meaning if you lose a connection, it can force a new connection. If the corpus callosum shut off and that was the end of it, you couldn't walk because your right brain controls left leg, right? So it doesn't shut down completely, and the brain will usually try to find a new way to connect. And so if you practice enough, you can form a new connection, which maybe gives you the ability to read, but you're not using the right pathways. So when you go to read, this might go like this to get there. How much longer does it take to process letters if it takes that route versus this route? Okay, it's like if you were to go to your house and there's a sidewalk that goes from the street right to the front door, and instead of going right down the sidewalk, you decide to zigzag back and forth across your front yard 10 times before you get to your front door. I had to read it 10 times because I was zigzagging across the front yard before I got there. Now what happens when this occurs is it takes longer to process. Okay, so if I said what's 1 plus 1 plus 2 plus 5, you may not be able to know what the answer is because it took too long for the information to get where it needs to, and you couldn't follow fast enough. The other problem is when this shuts down is you may only get part of the question. If I asked you what color is George Washington's white horse, A, gray, B, black, C, brown, D, white. Is that a question? George Washington horse. That's all my brain processed because the rest of it got lost. And I don't even know that was a question. Okay? So this is where dyslexia and a lot of learning disabilities stem from, is really just from the brain wiring. Okay? When you're looking at ADHD, okay, if I was to look at the tip of my finger here, this is the focal point. Okay? If I'm looking here, all of this is my peripheral vision. With true ADHD, the pathways in the brain that cross focal point aren't working, and that becomes a blind spot to the brain. Your eye can see it, but your brain cannot process it. So if I'm looking at a word that says, we'll use brain, and I'm looking at the word brain and my brain can't process focal point, what do I see? Because I can't process the focal point. And the only thing I process is what's in my peripheral vision, B, R, N maybe. Okay? Or if you have the word the brain, okay, and I'm trying to read the brain, and my brain processes the, and I get thane, because that's what my brain processed. So reading became really hard for both dyslexic and ADHD children as they're learning to read because of the way the brain processes things. Okay. So with the white matter, okay, this is I told you those are high-speed pathways, and so there's pathways that go. This is your inner brain, like your peanut again. There's pathways that go this way called projection fibers. They take information from top to bottom. Okay. You also have pathways that go this way that take information from left and right. And then you have pathways that go from front to back like this, okay? And if you lose those pathways, you can't even get information where you need to. So if you lose the projection fiber, or the association fibers that go, no, association this way, these are these are the projection fibers that go this way. Okay, you can't even get what your eye sees to the back of your head. And so your eyes go up here. Well, that's your frontal lobe. Your frontal lobe does all your planning, organizing. That's where all that happens. So if you can't plan and organize, it might be because you don't have access to your frontal lobe of your brain. Okay? But you might be trying to process your eyes there, and then you're not processing what you're seeing very well because they're supposed to go back here. So it's really important that both the gray matter and the white matter of the brain works correctly. If either one shuts down, you're a done deal.